All right. So just to start off, just to remind everyone that our exam is on Monday, and the way that it's going to work is that a little bit before 9 a.m., I'm going to email you a copy of the exam, and then you'll have effectively 70 minutes to get everything done. But that's going to include the way I break it down is 50 to 60 minutes for the exam, and then you'll have 10 minutes to upload a PDF of your exam to EC Learn. So I already took a look at the quick assignment that I sent you guys out earlier in the week about uploading how to take a PDF of a document from a picture and then uploading that to EC Learn. So if you haven't done that, just a reminder, if you get it done by 5 p.m. tonight, I'll give you 2 points extra credit on this exam. But I've already seen most people were able to do that pretty easily. So any questions on the design of the exam, like how long you have for the exam? Oh, sorry, I realized my audio is really low. What'd you say?
Do we have to print out the exam?
No, that's a good question. So I'll send out I think, if not, I'll send them out again. Because I'm pretty sure I sent it to my 1102. I thought I sent it to you guys. But just in case. No, you do not need to print the questions. If you have a printer, it might make it easier, but I don't expect anyone to have that, so you can just write it by hand. You don't have to copy over the problem, like the wording, just literally the number, and then show me your work. That's it. All right. So the breakdown of the exam is going to be identical to the one you guys took for exam one, where it's 15 multiple choice, 6 short answer, which are more just like, here's the problem, do it type questions. And then one, what I call it a multi part question, where it's one of like those combining ideas type question, where I'll give you one set of information and then I'll ask you a series of questions that might be from different chapters. And so that's the way it will break down, just like last time. So is everyone on board with that? Any questions? All right. And so I think you guys are starting to pick up on that. I'll wait like a couple of seconds for anyone to chime in. If you're not comfortable talking over the mic or don't have a mic, you can also use the chat and I'll see that.
Wait, so there's
Mhm.
6 open response, and then what's after the open response?
Just like it's like one multi-part question. Last time I think there was like
Oh, okay.
4 parts. So is that a gold question I
All
had you
right.
guys do? Yeah.
All right, thanks.
Yep, and just for a heads up too on grading. So because I have 90 students, like including you guys plus my other classes, I can't scan everyone's copy of their exams. So I will grade them. You'll have the grades, but what I'll have to do is I'll send you a very detailed answer key so you can see exactly what points or what steps were worth what points. And then I'll have an exact answer key so you could theoretically go back over your work and figure out where you went wrong. And so if you have a huge discrepancy, then we can have a talk, and then I can scan we can figure it out. So that's my plan, at least for right now.
Did you say the test was going to be open notes?
I mean, theoretically it's not, but I'll leave it at that. Yeah. Any other logistical questions? All right. So we're good. And again, you guys, I know there might be a delay, so even if I'm talking, just interrupt me. We're doing the best we can. All right. So you should be screen sharing with me already. It should be the practice problems that I sent out, I think yesterday morning or something like that. Is that what everyone's seeing? Just get a quick yes from someone. I just want to make sure you guys are seeing what I see.
Yeah.
Okay, cool. All right. So I'm tossing it out to you guys, or else I'm just going to start doing random problems. Is there a particular focus we want to start with? Even if people want to yell out multiple ideas, it's a way that we can start to tackle different problems. And I'll let you guys
Can we
think.
start with
Yep.
a stoichiometry question?
All right, so I just got 3 people talking at once, so maybe that might not work. Let's try to take. So, Caitlin, I saw you talking, and I heard your voice. Why don't we, Caitlin Lee, right? You were talking. Yeah. Why don't? Yeah. Okay. You were clear. What was your question?
Can we start with the stoichiometry?
And so stoichiometry is a really broad for like word. Are you talking about like going grams to moles, moles to grams type thing? If I give you, yeah, then we can definitely do a reaction problem like that.
Okay.
Definitely.
Thank you.
Yep. Anyone else want to have an idea for a type of problem?
yeah, can we do like one of the more complicated questions about moles?
And so again, like I need to know because I know it's easier when we're together because then I can kind of interpret what you're saying. It's hard to see without body language. Like when you say complicated problems with moles, what is that? Even give me like an
Just like
example.
one with more than one step.
Okay, yeah, so that goes along with what Caitlin said. So a stoichiometry problem would be something like that. So I can try to combine
Yeah.
those two together. Any other ideas? Because we could start with that if we want.
I had a question from the mastering.
Yeah.
So, like the how to find the conjugates and then also like dissociation in water equations.
Yep, we can do two of those too. So how to find? Sorry, again, I just blanked. You said how to find?
The
Oh,
conjugates.
conjugates. Yeah, that one's easy. I mean, I just need to clarify. I'm saying maybe it was my fault. It's a clarification problem. It's probably really simple. I think. So how to find conjugates, and then sorry again. What was that last part?
The dissociation in water equations.
Okay, yeah. That's probably me needing to clarify because I know chapter 10 is a little bit big. So actually, why don't I do that first because I think it'll be simpler, and then we can jump into those mole problems that we were talking about earlier. So what I'm going to do is I'm going to stop sharing for a second and switch over to just a blank document. And so I should be able to write there. All right. So let's talk about conjugates first. Oops, wrong tool. So we were looking at technically conjugate bases. And so what that means is if we have an acid, say like hydrochloric acid, or maybe we have something like sulfuric acid, or even something complicated like acetic acid. So all of those are acids. And all of them, and I'll have to tell you exactly which protons are going to move or which hydrogens are going to move. But everything that I just highlighted, at least one of those hydrogens is acidic, which means it will be transferred. And so if these are our acids here, their conjugates literally write the equation minus 1H. So the conjugate base of HCl is just chloride. The conjugate base of H2SO4 is HSO4 minus. And then here, technically I just highlighted the wrong H, but it should be also just losing a single H. And I'm not going to worry for you guys right now. We'll do this in the next couple of chapters, figure out which one of these H's is actually acidic, but that takes orgo. So we're not going to deal with that. So is that more clear on what a conjugate base is and how to identify them, or do we need to go a little deeper?
If they're asking you to find the acid, do you just add an H?
Yep, that's it. So we can see when you're going to conjugate, just draw the structure or write the name with one more H on it. Right now, so I don't know if mastering chem is going to be difficult. If it is, like, you know, if it frustrates you, let me know. But like on an exam or the exam, it would be as easy as this because I want you to get the main idea. I'm not trying to trick you on this. So like I said, if there's a conjugate base and I want you to draw the acid, just give me one more H. If you want to draw the conjugate base from the acid, remove an H, and I guess the other step would be then to drop the charge by 1. Does that make sense? Let me give you one more example so it's a little bit more. What if we took the, so if we have an acid, and let's take that HSO4 minus, which I drew as a base in the last example. We didn't go into this, so don't worry if it doesn't make that much sense. I just want to use it as an example. But some acids can start as ions like this. And if I wanted to draw the conjugate base, again, I follow my same rules. Take off that acidic proton, so I become SO4, and then drop the charge by 1. Becomes sulfate. Is that clear too? We okay with it? So guys, I don't want to, so the thing is I'm going to need feedback because I don't want to, if I'm losing you or not because it's difficult. Like in the room, I can read if there's like confused faces. Right now, I'm going to have to use your voices. So are we good?
That's good.
That's
Thank
good?
you.
Okay, yeah. And what I've noticed too, and like maybe everything is clear, I've noticed a lot in all of my classes, everyone just gives me affirmatives. If you're even the one person who doesn't get it, we can go back. right? So let me know if something is like throwing you off. It's probably not just you. All right, and so the other one we were talking about was how to write a dissociation reaction in water, right? And specifically, this is for acid bases, right? You could actually do it for salts as well. It works just as the same. So if we had something, let's take an acidic example first. If I took something like nitric acid, usually starts as a gas. It doesn't always. I'm not going to have you guys know what what states they're in to start with. I'll tell you what they are. So it's going to start as a gas, and if I was going to write what happens when the acid dissolves in water, right? So I write water over the arrow because it's telling me it's going into solution. And then what I do is divide it up into whatever the cation is going to be, and then whatever the anion is going to be. So the nice thing about dealing with acids, one of them is always going to be an H+, and it's got to come from something. So it's almost following the exact same rules of the conjugate base. We see we already took off the H+. It leaves with an NO3-. And then just to make sure, this part I would require is knowing that they're aquated. So are we using that state of matter? I would not have you know off the top of your head that like nitric acid would be a gas before it was added to water. So that's not something I'd expect. If we were doing a base, well, actually, let me go one step deeper with acids. So with acids as well, there's another way to write it out, because even though we wrote it as dissolving up here, acids also actually react with the water themselves. And in this case, if we're following the acid, that acidic hydrogen is going to go to the base, in this case water, and it would protonate it. And so that's going to leave us with our NO3-. So we effectively get the same anion. But instead of writing just, let me actually put them underneath each other. So we get the same anion, but the way we're going to write that second product, the cation, is going to be in the form of hydronium. The reason for that, we don't really get into it, and it's not that important for us, but free protons are incredibly unstable, and they'll spontaneously basically break up into smaller particles in a couple of minutes. So technically, this is a little bit too vague. But the idea of writing a dissociation reaction, like I've shown here, it's exactly what I'm expecting. Do we want to do another one, or does that clarify the problem?
So they could.
Yep, go ahead.
Okay, so those are two. They're both dissociation reactions.
Yeah.
Are
So let me do this, because I realize the acid one is probably a little bit more vague because it can be written two ways. Yeah, let's do something that's not vague. How about that? We'll take something like sodium chloride. It's a super easy example, right? And then we could also apply it, and I'll do it on the afterwards, is apply it to the base sodium hydroxide. If I was going to write a dissociation reaction for this, sodium chloride, you pull it off the shelf or even in your kitchen. That's just table salt. It's a solid. You're writing it as it's dissolving into water. And again, all I need to do is identify what is my cation and then what is my anion. Once I've done that, you draw them as separate pieces. And then we say that they're aquated, right? And the reason we have this type of reaction is because in real life, when you have a sodium cation floating around, right, that's a positive charge. It's because the partially negative end of the water is going to line up and actually makes an entire cage around it. And we'll do the same thing with chloride, except in the reverse order, with that partially positive end of water being in contact with the chlorine. So that's why it's not just like an arbitrary thing we write, but it actually has meaning. So let me just do one more just so we can hammer it home, just to bring it full circle back into acids and bases. So sodium hydroxide is a base, so it's basic, and we can draw the same dissociation reaction. So sodium hydroxide is just pellets. It's really common. You can go into any lab, pull it off the shelf. Again, we dissolve it into water. I identify what my anion is. I identify what my cation is. I separate them. Indicate that they're surrounded by water by saying they're aqueous. And that's it. That's how you write a dissociation reaction.
And so the one you wrote with the HNO3 plus the water,
Mm-hmm.
and
Yeah.
that's just a different flavor.
It's the book. Maybe that wasn't a good place I should have gone because the book kind of shows it as both, though technically it's an acid-base reaction. If I was gonna say, if you're looking for a definitive example, go with this one or the sodium chloride example. That's when I ask for a dissociation reaction. That's what I'm looking for.
Okay.
Mm-hmm. Yeah, just make that super clear.
Good, thank you.
Yep. All right, so are we ready to move on from the idea of conjugate bases and dissociation reactions? All right, I'll take the silence as yes. And so we'll go back to the original questions asking about moles. So instead of making one up, let me take a quick look and see if there's any good Chapter 7 problems we could look at. So give me, 30 seconds. Oh, I'm hitting the wrong thing again. I get two screens, it gets confusing. All right, let me try doing this. So I'm going to leave you on the blank screen for a second while I take a look. So let's see, what page? Unless someone has a problem, I can make one up too, but. So let's go to 319. All right, my internet's just going a little bit slow because I'm taxing it with so many things on it right now. I think I got a good one here. Let me just read through the whole thing. How about this? So this way you guys can look at the exact same problem and I don't have to write everything out. I'm going to share my screen, but if you have your book, I'd recommend opening it up to page 319. And so I think, and it's funny, it's kind of fitting too, is a question, the combining ideas, right, from chapters 7 through 9, the CI.15, the one about Tamiflu, is probably, if we want to go through, say, all of these, these steps, see how many we can get through, that's going to take, basically deal with, I think, Abby, you were saying the idea of like a complicated mole problem. And then it'll also take Caitlin's idea of like dealing with stoichiometry. And so I'll combine those two ideas together. So also what I think might be a good idea. So we have, we're going to 9:50, so we still have a half an hour left. I tried figuring out that, I'm going to do more work over the weekend. I've not been able to figure out how to extend without purchasing something. The Zoom beyond, like a meeting beyond 40 minutes. So why don't we take a break? I'm going to send a new link out. Rejoin me, and then we're going to start in like 2 minutes. Sound like a plan? All right.
Yes.
Cool. All right. I'm going to stop the meeting, and then I will pick right back up in 2 minutes. Wow, the internet is really grinding to a halt this morning. Wow. I don't even know what that error is. All right, cool. That was really quick, Summer. I literally sent it like two seconds ago. Amazing.
Thanks.
Yeah.
Also, I apologize.
Mhm.
The PDF upload.
Mhm.
Did you send out an original email that explains?
Yeah, I should have. That's the thing. Yeah, I know how hard it is to use Outlook too, because now that I've been receiving a zillion emails, finding attachments has been a brutal challenge. I'll put it that way.
Yeah.
Another B word. Yeah. What I can do then, Summer, why don't we just, you're going to have to just go to page 319 today on your book, and we'll deal with that. What I'll do is I will double make sure that it's there, and if it, even not, I'll email you directly. It'll just have to be probably not until 1. I know me and you have office hours at 12, but like I won't have a chance until 1.
Yeah, no problem. That's fine.
Cool. All right.
Thank you.
Yeah, no problem. So let's get over to here.
Actually, yeah. So I did find your email. If I in the search bar, if I do PDF upload,
okay,
it comes up.
That's good. Yeah, because I know you all must be probably inundated with as many emails as I have been. So
yeah. So yeah, you're fine. You sent that.
All right. So seems like the majority of the class is back. So why don't we get started on this? So let's read through it first, and I'm not going to write on the screen because I'm going to need to write everything down physically, but we'll come back to it. So maybe as I'm talking, you might be wanting to make your own lists of givens and finds, because that's exactly what I'm doing right now. So it's kind of a fitting question, but we're starting with Tamiflu. And so the first thing I'm going to write down, just so I have it written down, is going to be the chemical formula. So C16, N28, N2, and O4. So it's quite a big molecule. It says it's an antiviral drug used to treat influenza. The preparation of Tamiflu begins with the extraction of shikimic acid from the C pods of star anise. So it says the mass of star anise, I'm going to call it SA, is 2.6 grams. It says the mass of shikimic acid, I guess I can't use SA again, I'm going to call it SH, is 0.13 grams, can be obtained and used to produce 1 capsule. So 1 capsule containing 75 mg of Tamiflu. It says the usual adult usage for treatment is 2 capsules, so 2 caps per day for 5 days. And then it gives us, a bunch of questions to answer. So all I want to do is start simple. We'll just start with A. So I need to write it down so I can switch because it's going to blank out my screen from this, but have your book open. So it says, if black spheres, oh, you don't have to do this one. That one's not going to help us. Let's start with B. It's going to ask us for the molar mass of shikimic acid, which is surprisingly used more often than you would think. That's how I know how to pronounce it. All right, so we can already see, we already even wrote down, and you guys can see my projection from my, well, you guys can read too. I think you can see my screen. So I should be on page 319. You guys can see that? Okay, so what I'm looking at, let me see if I can start drawing on the screen. And so we're trying to figure out the molar mass, right? That is our ultimate goal now. Anyone want to jump on telling me exactly, how I want to go about determining the molar mass of shikimic acid? Oh, wait, no, I jumped ahead. My bad. We do actually have to figure out. I'm going a little too quick. let's go back to question A, because we need to do that first. It says, write out what is the chemical formula of shikimic acid. So how am I going to know that? It told me that I have the structure of shikimic acid is down here. It mentioned that black spheres are carbon, white are hydrogen, and red are oxygen. So why don't you guys take 2 seconds? I'm going to do it too. So, try to get the practice. I'm going to go through, let's just figure out how many C's, how many H's, and then how many O's. And it's typical for chemists to write them in that order. You'll even see up here. We don't have nitrogen. It usually gets inserted after H, but we see the CH and O. So let's go through. So I'm seeing 1, 2, 3, 4, 5, 6, 7. 7 carbons. Do you guys agree? Well, if you see me do something dumb, jump in and yell at me. And then if we do hydrogens, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I have, let's see, how many oxygen? 1. Go ahead, make a note, mark. 1, 2, 3, 4, 5. So I'm not really going to do too much of that on the exam. It's just that we need the chemical formula to answer the next question. So we have Tamiflu's molecular structure, and now we also have shikimic acid, so C7H10O5. Anyone else disagree with me on that? Because, I'm doing this at the same time you are. All right, so let's readdress the question we were being asked to do, which was question B, molar mass of shikimic acid. So now that we have the C7H10O5, right? Can someone just suggest how would I solve this question? How would I find the molar mass from this formula? Or what could I do?
You could find the mass of each of the elements and then multiply by how many times the element appeared in the equation.
Exactly. That's what we want to do. So where am I going to find that information in terms of the molar masses of each individual atom? That's the next question.
Above the atomic symbol in the periodic table?
Actually, it's going to, at least the one I'm looking at, so maybe it might be flipped on your guys's. My atomic numbers are on top. Those are the whole numbers. The numbers we want to look at are the numbers that have like multiple decimal points, because those are going to be the masses. But it just might be because I'm using a different periodic table. So if you don't, I would go somewhere in your book or just Google it real quick. Pull up the periodic table, but I'll do it pretty quick. I'm just going to go to say 3 significant figures. We know we have 7 carbons. If we look at the periodic table, the molar mass of carbon is 12.01 grams per mole. Right? We said we used to talk about it in terms of AMU, or atomic mass unit, which was for the weight of 1 atom, but now we're talking about a mole of carbon, so it weighs 12 grams. We have 10 hydrogen, each one of them weighing 1.01 grams per mole. And I pulled that off the periodic table. And then we have 5 oxygen, and that's going to be 16.0 grams per mole. Sorry, I'm kind of making a mess on that. I don't have a lot of space to write, but I want to keep the problem we're working at on in front of us. So if we do that math out, 7 times 12.01, I'm getting 84.07 from the carbon. 1.01 times 10, I'm getting 10.1. And then 5 times 16, I'm getting 80.0 from the oxygen. So if I add that up, I'm getting a molar mass of 74.17 grams per mole. If I want to apply sig fig to this, technically I'm limited to only 1 decimal place, because we got to still remember our addition sig figs, right? Here, when we're multiplying across, we were just talking about 3 sig fig. These are infinite because those are whole numbers, because you can't have anything other than 7 carbons per molecule, or 10 H's or 5 oxygens. But when we add them up, our rules change a little bit. So even though actually this should be probably rounded here, but our let me do that. This should be a 1 then. And it doesn't matter, actually rounds to the same number. But with correct sig fig, I get 174.2. So has anyone lost so far on what I've done in terms of determining molar mass? Because we're going to start doing the stoichiometry in the next couple of problems. Yeah. All right. So let's take a look at the next step. So if we're able to figure out our molar mass, the next question is asking how many moles of shikimic acid are obtained from 130 grams of shikimic acid. I'm just trying to write down really quick so I can make sure I don't screw up. All right, so if we're attacking that problem, let me switch over now just so we can write a little bit bigger on a blank screen. I don't know why I switched to that one. It's not what I wanted. All right, I'm having some issues. Hold on a second. All right, so we should have a blank screen up. So we have our shikimic acid. And I figured out that its molar mass is 174.2 grams per mole. So the question is, how many moles of shikimic acid are in 130 grams of shikimic acid? And so this is going to be our most basic type of stoichiometry problem. So I know I'm going to basically have to walk you guys through it just because, you know, it is going to be hard to get feedback, though. We're going to try to work on it and try to figure out a better system. So the way we usually start this, we start with what we're given. I have been given 130 grams of shikimic acid. It's asking me where am I going to go, how many moles of shikimic acid. So I got to set up some sort of dimensional analysis so they end up with moles of shikimic acid. So I got to multiply something through. So is anyone seeing any ideas that we might be able to somehow? Let me ask the question this way: what units would I need in the denominator and the numerator to get grams to cancels and then to get moles on top? Does anyone have a suggestion for that?
You would need grams in the denominator.
Yep, I agree. And then what do we need in the numerator?
Moles.
Exactly. And then in this case, we're going to be a little bit specific. And let me just erase that and just put it like this. Right, it's going to be grams. We want to make sure we're specific. It's shikimic acid. Oops, I messed up. We want moles on top. So moles shikimic acid, grams shikimic acid. All right, so I figured out what units I would use, because if I look here, without even dealing with the numbers, grams cancels with grams shikimic acid. So I've got to the unit that I want, because my unit needs to be in moles shikimic acid. So what number or what conversion factor can I use to finish this problem off?
1 mole of shikimic acid for the molar mass.
Exactly. And that's exactly how I would set that problem up. If, like I said, 99% of the time, if you can get your units to cancel and end up with the units you want, you have done it correctly. And the only reason I say 99% of the time is because it's It's been 100% of my time, but I'm pretty sure there'll be some point in my life I'll find out something doesn't work. So I'm getting this number here, but I want to make sure we apply sig fig. So I'm just going to copy it right off my calculator. So I get 0.746268. I'm going to stop at 7. So I take a look at what I have. It's a little ambiguous. I'm going to call it 130 grams exactly. So I'm going to call that 3 sig fig. And on the exam, I'll be explicit. I have 4 up here, so it means my final answer must be in 3 sig fig. So if I do that, well, nothing rounds. So that's going to be my final answer. So I know Caitlin and Abby, this was one. Oh, I don't know if this was like we haven't got to the hard part yet, but are we on board so far for people who asked about this?
Yeah.
Okay, good. So let's keep moving on with our problems then, because we still got a good amount of time. So that's good. All right, so I'm going to switch us back to our textbook. If it wants to behave. There we go. All right, so the next question is D. Yeah, let's keep going in order. So how many capsules, right, each containing 75 mg of Tamiflu could be produced from 155 grams of star anise? All right, so some of the things that we're going to need, so we might need to go back and pull some stuff out. So I'm going to need some information. Let's see. So we're saying how many capsules, right? So we already said if we look at our givens and finds, we're going to need 70. So it's saying 75 milligrams of Tamiflu per capsule, right? It's saying we have 155 grams of star anise. And I'm missing some bits of information. It's saying that 2.6 grams of star anise. It's saying will produce 0.13 grams of shikimic acid. Wow, this is a complicated problem. And it's saying that there's how many grams of shikimic acid? Oh, I got to read this a little bit slower. This problem is actually pretty complicated, so it'll probably be a good final example to do because we only have about 12 more minutes. So I got to read it a little bit slower. So it's saying the preparation of Tamiflu begins with the extraction of, from 2.6 grams of star anise, we get that much shikimic acid. Okay, and that's how much goes in one capsule. Containing, and then it's saying 75 mg. Okay. For 5 days. All right. I think we're in good shape. That is a complicated problem. So why don't we go through this one? It's more stoichiometry, less molar mass type stuff. So Abby, I think you were the one who was asking me that. Maybe we could, I know we have office hours today, so maybe we could readdress it if I don't get to exactly what you want. But I think this is actually going to be a really good dimensional analysis problem. So let's take a look at what it was asking us to do. So effectively, it's asking, how many capsules can I make, each containing 75 milligrams of Tamiflu from 155 grams of star anise? So that's not an easy problem. We're actually going to have to set up a pretty, I think, just by glancing at it, not elaborate, but longer than what we usually would do in terms of like setting up dimensional analysis. This is where organizing things into givens and finds are really going to help, right? Some information that we have is that we know there's 75 mgs of, I'm going to use TF as an example, as a shorthand for Tamiflu. So it's saying that, and maybe I'll change this to a different color. it's saying we have 75 mgs of Tamiflu for every 1 capsule of, 25, for 1 capsule. Yeah. All right. We also know that our mass of starting with, that we start with for star anise is going to be 155 grams. We also got from the reading that for every 2.6 grams of star anise, we can extract 0.13 grams of shikimic acid. Maybe I should write that out because star anise and shikimic acid both have the same initials. And each of these make up 1 capsule. So that's a lot of information. So what I want to do is identify what I'm starting with and where I need to go. How many caps? So it's saying I'm starting with this amount. I need to get to number of capsules. I'm kind of looking here. This might actually be unnecessary information, but we'll find out if we need it. So I'm going to have to clear the screen. So again, the recording is still going on, so that's good. So if you have to go back and go slower, that'll be fine. But because we only have 9 more minutes, I want to make sure we get through it. So as always, what we're going to do is we're going to start with what we were given. I know the only thing that I have is 155 grams. And then really quick too, to make sure I didn't mess up my units. Can someone just confirm it is 155 grams and not milligrams?
Yeah, that's right.
It is
Yeah,
grams? Okay, good. All right, so I know I'm starting with 155 grams of star anise. And I need to set up a plan to somehow end up with the unit of capsules. So what I need to take a look at is a bunch of my conversion factors. So I'll put those on the bottom in a different color. And then we can start to see if we can mix and match to get ourselves a roadmap to work. So one of the conversion factors we know that 75 mg of Tamiflu will be in 1 capsule. We know that there's from 2.6 grams of star anise, we can extract 0.13 grams of shikimic acid. And this one's a little bit of a stretch, but I'm going to say that I'll call them, if star anise and the shikimic acid, actually, yeah, my bad. And then 0.13 grams of shikimic acid. My bad. Sorry, guys. I'm getting a little ahead of myself. We also know that 0.13 grams, of shikimic acid is in 1 75 milligram dose of Tamiflu. So other things in drugs, I know it's a little weird when you're hearing that. A lot of things in drugs are filler. They're usually just like plant byproduct, so it's like a binder. Because 0.13 grams is very small. So it's too small to make a swallowable tablet out of. So the majority of the medicine you take is usually cellulose or something like inert. So that's probably why you're seeing that, like, the active ingredient is the shikimic acid, right? All right, so let's see if we can set up a plan. And I'm just going to go with my units, right? I'm going to write this a little bit smaller, but I'm going to just set up a plan with my units and see if I can get to the units that I want. So my plan of attack would be to figure out, okay, it's 155 grams of star anise. Well, I know I need to get rid of star anise. And I take a look at my conversion factors that I've summarized. Well, oops, I keep going to the wrong thing, sorry. Star anise, well, I have a conversion factor that I can at least switch to the top, grams of shikimic acid. So then I keep working, just go piecemeal. What can I do with that? Well, my next thing I see is that if I have this much shikimic acid, well, that's how much Tamiflu I could make from it. So let me try setting that up. So if I just have grams shikimic acid down here, I could make a certain amount of milligrams of Tamiflu. And then I take a look, what else could I use? Well, I know if I have this many mgs of Tamiflu, I can make that many capsules. And that's exactly where I'm trying to get to. And so even though I've kind of run out of space on the screen, right, what I was able to do was just that was a tough problem. Even for me, you can see I'm trying to keep up with that. That was a lot of information. But stepwise attack is going to help organize yourself. So this is probably the longest dimensional analysis problem we've ever done. So we got about 4 more minutes. So why don't I do this? I'm going to dump in our numbers, and then we'll solve this and see what we get. And then later, probably not until tomorrow, honestly, it's going to take me to get the an answer key done, where I'll do all of the problems for you, but I'm finding that I'm overwhelming myself with trying to make so many videos, so it's going to have to be just an answer key. But maybe if there's a certain difficult problem, I might make a video on it. But that's just a heads up right now. So if I go through now, and I've done all of my work with my units, so gram star anise, gram shikimic acid, mgs Tamiflu, all of my units cancel to the unit I want. Now let's throw in our numbers. So we used this conversion factor first, and so I know that for every 2.6 grams of star anise, I can extract 1.3 grams of shikimic acid. For every 0.13 grams of shikimic acid, I can make 75 mgs of Tamiflu. And for every 75 mgs of Tamiflu I can make, and I already wrote it up there, 1 capsule. So just to save space, I'm going to erase our conversion factors. In one little side note too, in case maybe people were getting a little confused or I'm going a little too quickly, is that, remember, conversion factors, you can flip them and they mean the same thing. We're not treating them like fractions. We're treating them as like statements, right? There's 0.13 grams shikimic acid per 2.6 grams of star anise. You could also say that for every 2.6 grams of star anise I produce or have 0.13 grams of shikimic acid. All right, so let's go through real quick. We got a couple more minutes. Finish off the problem. So 155 times 0.13 times 75 times 1 divided by 75 divided by 0.13. Oops, I put a negative somehow. 155 times 0.13 times 75 times 1 divided by 2.6 divided by 0.13 divided by 75. 59.6 caps. Well, I'm limited to 2 sig fig in most of my numbers, so from 155 grams of star anise, which is probably what you can, that you'd easily buy that at the store. It's not too much of the spice. You can make 60 capsules of Tamiflu. All right, so I know that was actually a fairly complicated problem, but maybe go through the video again if you're still having issues with the stoichiometry aspect of it. But this was a tough problem, something like this. This is a tough one. But if you feel comfortable with it, probably means you're in good shape for doing stoichiometry problems. All right, so I'm going to stop sharing. Oops, I guess keep forgetting to turn off my stylus. Here we go. All right, so we're down to 1 more minute. I can spend a little extra time afterwards. I just got to prep for my next class. Is there any last questions about the exam or anything like that?
I have a question on what you just did.
Yes.
So I was doing this earlier, and so I found that in 1 capsule you have 2.6 grams. So if you have 155 grams, I did 155 divided by 2.6, and I got 59.6. Would that always work like that?
Yeah. So I realized when I was doing it, there was a shortcut, but I was trying to show like how you would do it if you used everything. Yeah, there is a shortcut.
It's lucky.
No, it's not luck. You set up. You just made a different conversion factor that it goes a lot quicker. That's all.
Okay.
Yep, you're in good shape. All right, so I'll let you all go, but the last thing I want to say is I realized I'm going to try my best to not overwhelm you. I have moved the homework just in case you want to study instead of do chapter 10 homework. That's fine. The homework, I'm going to give you a little extra time until Wednesday to get it done. So there shouldn't be a crush. Spend some time studying, get the homework done. I think it's good practice. but don't let that dominate your time. If you need to push it to Wednesday, push it to Wednesday. There'll be no penalty. All right, we all set? All right. So I will see you all on Monday. I'll email you out. Well, I'll send you instructions. So you're going to get a lot of instructions over the weekend on what to do. And expect an answer key either tonight or tomorrow. Probably tomorrow. All right. You can start logging off if you'd like.
Thank you.
No problem. We'll see you all later.
Thank you.
Thank you.